Okay. So yeah, let's get into it here. All right. Ooh, okay, welcome everyone. This is Dan from Dan's Test Prep. Today's Tutor Tuesday, and we're going to go over some digital SAT practice questions. I'm going to put you guys off to the side here, the chat. If anybody has any questions, paste them in the chat here and I can put them into the whiteboard. And yeah, let's get going. So I've got a question here about the DSAT. Yeah, if you're in ninth grade, then you likely have a lot of prep time before you have to take the digital SAT. So you might be taking like the PSAT, but the test is a little bit shorter. It tests mostly the same concepts. Honestly, just if you're in ninth grade, pay attention in school and make sure you're like learning all the concepts there, because that'll be most helpful for you. You don't really have to do any targeted prep, but you can if you want to use Khan Academy or something like that. Yeah, algebra is a big part of the test. So actually, I have some. I could pull up some algebra specific questions if you guys are looking to go over that, and we can turn this into kind of like a basics of the SAT sort of thing. So let me go ahead and I'll pull up our algebra topic. We'll start off maybe like medium difficulty and see what you guys know. So let me paste in this question. If there's any other topics you guys have that you want to suggest to me, feel free and I'll find a question on that. This topic is linear functions. So anyone want to take a shot at this? Let me know in the chat what your answer is. So this is linear functions. This is kind of like a medium difficulty question that you'd see as part of the algebra. The answer is okay. Let's go through how to solve this one. So it says the graph of h of x that's given here has an x-intercept at a comma 0 and a y-intercept at 0 comma b. So a and b are constants. What's the value of a plus b? So you can very easily solve this out by hand, or probably even more easily through Desmos. I would probably use Desmos just because I don't want to make mistakes, but let's plug it in by hand and see what we get. X-intercept is at a comma 0, which means that the y value, or the output, is 0, and the x value is a. So we get something like 0 equals 4a plus 28. So let me label this. This is for the x-intercept. 0 equals 4a plus 28. Then we get something like 4a equals negative 28 if we move that 28 to the other side. And ultimately, we'll get a equals negative 7. So we've solved part of it. To get the b value, we have to consider the y-intercept, which is when x is equal to 0 and y is equal to b. So that'd be something like b equals 0 plus 28. So that's a little bit simpler. That's just b equals 28. So in total here, what we're going to get when we're asked for a plus b, it's going to be negative 7 plus 28, which is going to be 21. Questions? We do maybe another, we can do a little bit of a harder one. I'll find one for you guys. Yeah, this one is a good practice. Okay, so this is another linear functions question, but it's a bit of a harder difficulty. Anybody have any ideas how we can go through this? Oh, streamer problem. Yeah, let me put the questions in a chat as well. And I'll be recording all this and posting it for you guys. But this one is saying a window repair specialist charges $220 for the first 2 hours of repair, plus an hourly fee for each additional hour. The total cost for 5 hours of repair is $400. Which function f gives the total cost in dollars for x hours of repair, where x is greater than or equal to 2? Okay, so what I'm thinking, or initially you might think that your y-intercept is at 220, but that wouldn't be exactly correct. Let's actually break this down. So it's 220 for the first 2 hours. And then in total, it's $400 for 5 hours. So, the way we could represent this as a function even is we could say the total cost is equal to that base of $220 plus, let's say, n, the hourly rate, let's call it as n. And let's multiply this by x minus 2. This is saying that after 2 hours, or this is only basically applicable for x greater than or equal to 2. But we can then transform it into one of these forms. So 220 plus n times x minus 2. This is saying that after 2 hours, the hourly rate of n kicks in. So let's simplify this a little bit. We'd get so f of x basically becomes f of x equals 220 plus nx minus 2n. Or, maybe it's just best we keep it in this form and we substitute in some values. Like, for example, we know that f of x equals to 400 whenever x, or the number of hours, equals to 5. So here I've just substituted in the values. 400 equals 220 plus n times 5 minus 2. If you subtract off the 220, what you're left with, so this cancels out, you have 180 is equal to 3n. So this tells us that after 2 hours, the hourly rate of n ends up being 60. So, right, we know that he charges $60 per hour after the first 2 hours. That would make sense if, let's say, the first 2 hours we charge 220. We have 3 more hours to go, over which he charges $180 to create a total of $400 over those 5 hours. But the intercept is the real issue here. So we know the slope is 60. Is the intercept 100 or 220? So to find that intercept, we can kind of look back at this equation. We can now that we've got the value of n, we can substitute in and get 220 plus 60 x minus 2. That simplifies to 220 plus 60x minus 120. 120. And that simplifies down to 60x plus 100. So that was really tricky, misleading question, right? You might think that we take 400 divided by 5 to get that cost as 80x, but it's actually going to be $60 per hour because x is greater than or equal to 2. We don't consider the first 2 hours inside that hourly rate to calculate that 60x. Then when you consider that when x is equal to 2, the function has to equal to 220, you can substitute that into this solution and find, for example, f of 2 is equal to 60 times 2 plus 100. So f of 2 is definitely equal to 220 like we expect. That's not going to be true for answer choice B, however. Okay, I see we have a question in the chat. Looks like a nice right triangle problem. And on the SAT, you might have some kind of question like this. So let me also paste in the reference sheet for the SAT, because that has some formulas that will be useful for us. Yes, it's a 45, 45, 90 triangle. So we know that the sum of the angles, of the interior angles of a triangle is 180 degrees. So not only do we have 45 here, but we have a 45-degree angle up here. I'm trying to find the best color here. So this is also 45 degrees because this is 90, this is 45. To sum up to 180, we need this one to be 45 as well. So if you want to find the lengths of the missing sides, AB and BC, on the SAT, you can use this formula right here, or use this diagram, which tells you that if your side length of a leg is S, the hypotenuse will be S root 2. So, for example, we could label this as S, this is S, and 12 is equal to S root 2. Well, if 12 equals to S root 2, we can actually solve for the value of S. 12 equals S root 2. So if we want to solve for the value of S, we can just do 12 divided by root 2 and get S. You might want to then rationalize this answer, in which case you can multiply both sides by square root of 2. So you have this, you multiply the top and bottom by square root of 2, so it'd be something like times root 2 over root 2. Because this right here, multiplying by root 2 over root 2, is the same thing as multiplying by 1. It doesn't actually change the numerical value, it just changes the form of the answer. So that'll then simplify to 12 root 2 over 2, because square root times a square root cancels that out, equals S. Or finally, we get S is equal to 6 square root of 2. So each of the sides here is 6 root 2, and the hypotenuse is 12. Yeah, law of sines and cosines. Law of sines and cosines is something that comes up on the ACT for sure, but I'm not sure I've seen it used on the SAT that much, or really ever. But if you guys are interested, I could pull up a problem that involves those. If it might take me a little second to find it. Okay. I guess since we're on the algebra wave here, that kind of last one was kind of geometry, trigonometry. You guys let me know what topic you want to do, but I'm thinking to skip through the rest of the algebra questions. We could do, for example, a systems of equations problem. Algebra 2. Yeah, there's a lot of algebra 2 on the SAT. Let me look into some of the harder math topics. You might find stuff like nonlinear functions there, like quadratics, things like that. So I believe this question right here that I'm going to paste in a chat for you guys as well. This one is sort of like an Algebra 2 problem, specifically quadratics. I'll look for a polynomials question after this as well. So I think this is like a typical Algebra 2 problem. We have a rectangle as a length that's 15 times its width, and the function y equals 15w times w represents this situation. So y is the area, and y is greater than 0. We want the best interpretation of 15w in this context. It's not always that you have to solve something, but sometimes you just have to interpret something within the context of a math problem. So what do you guys think? What is 15 times w? They kind of already tell you in that first sentence, right? The length of the rectangle is 15 times its width. So yeah, if we have something like 15w, that's going to represent the length of the rectangle. That's going to be a. I have another. This is also sort of like an Algebra 2 problem here, dealing with analyzing the graph of an equation, polynomial equation. So for this, you need to be familiar with how graphs tend to look with their roots and their end behaviors and things like that. So here it's asking us, or we're given these three answer choices, and I see they all have a leading coefficient of -1/10. So we can't really rule anything out based on that. But we do have the different roots here. I see here, it looks like we have a root with a multiplicity of 2, or what I like to call a double root, because you can see when it goes up to that axis, it approaches it, touches it, and bounces kind of back. Here we see a single root at x. So you can see here it just passes straight through. And let's check the one at 4. So at 4, it looks like we also have a single root. I see some answers here. Multiplicities that are odd, that are even will bounce. So something like this that has a even multiplicity will bounce. That means it's probably going to be like squared or to the fourth or whatever. If we want to represent this root of -5, or let's call it a double root of -5, that's going to be x minus -5, and the whole thing should be squared. So that term in the equation is going to look something like x plus 5 squared. Single root of at x equals to 0 is just going to look something like x. Single root at x equals to 4 is going to be x minus 4. So the general form here is always something like let me write it here. The general form that you'll see for representing these functions is x minus the root, or x minus the 0. So it looks to me like the answer is going to be choice B. Yeah, we can tell if it's a single or double root based on how the graph behaves around that root. So if you look at the point -5, the graph or the function approaches that root, and then it bounces back. It doesn't actually pass through. And that's typical of something that has like a squared behavior, right? Like x squared, x plus 5 squared. Versus if it passes straight through, it's a single root or it's at least has an odd multiplicity. You can also tell that since the end behavior of this graph goes down, down, it also has to be an even function. Odd functions are ones that have different end behaviors. Even functions go in the same direction towards positive or negative infinity. So here there are 4, the multiplicity or the degree of the polynomial ends up being 4, which is even, that's good. The other ones have a degree 3, which means it would have sort of like a odd function behavior. Yeah. We can take some more questions, and I'll also look for some more Algebra 2 questions. In the meantime, I can look for even like one more medium question, and then we can go through some harder ones as well. Nice. Yeah, let's do this triangle question first, and then I'll go into the question that I had for you guys. This is pretty similar. Also, I'll paste the reference sheet again. Yeah, it's another special right triangle. It's also pretty typical of a geometry or trigonometry question that you'd see on the SAT. So you have that this angle measures 60. This is a 90-degree angle. Of course, the last one has to be 30 degrees to satisfy that the sum of all the angles in a triangle is 180 degrees. So we can kind of just corroborate this with the diagram that we have here. The shortest side is typically labeled x. The long leg is usually labeled as x root 3. And a hypotenuse is labeled as 2x. So we already have one of the sides labeled for us, which is nice. We can use that to solve and get 9 is equal to 9 equals x root 3. If 9 equals x root 3, then we can divide by square root of 3 to get 9 over root 3 equals x. Or x equals 9 root 3 over 3. X equals 3 root 3. That would make sense. If this is 3 times root 3, this is x root 3. We just multiply by a root 3, and that gets us back to 9. So x equals 3 root 3. Here we have 9. And then 2x is just going to be twice whatever this angle measure is. So we just double this into 6 root 3. So solution, if anybody can't see that, it's going to be like this. Yeah, laws of sine and cosine is not really going to show up a lot or I don't know that I've seen it really ever show up in the SAT. I know in the ACT you have to use it some questions. On the SAT you can kind of go without it. Hey, Elon. Yeah, you don't multiply that root. All right, why don't you guys take a look at this next problem that I'll paste in as well. I'm going to go nonverbal for a minute here, and I want you guys to put in your answers in the chat, or maybe vote on this. This is kind of like a medium Algebra 2 problem that you'd see on the SAT. And after a minute, we'll see what we get and see who's right. All right, we got a lot of answers. That's good. C or A? Well, let's think here. It's asking, or it gives us this long equation, ax cubed plus bx squared plus cx plus d. We don't need this actually. That's just saying that this is a cubic function. And then it gives us the graph. The graph is the most important thing. It's saying for how many values of x does f of x equal to 0? Are you guys ready for the answer? It's going to be 3. Yeah, it is 3 solutions. Because what it's asking here is when does the function equal to 0? You'll notice that the function is y equals f of x. So if f of x equals 0, or y equals f of x, and f of x equals 0, what that means is that y equals 0. So it's saying how many times, or for how many values of x does y equals 0? And that's happens right here, that happens right here, and that happens right here. It's not asking how many times does x equal 0, but specifically when does f of x equal 0. So that's going to give us the 3 points of intersection on this axis. All right, if you've got some other questions to submit, I can go over those. Otherwise, we'll move up in the difficulty to the harder nonlinear functions. Arcs, yes. Let me do this question. Let me do, okay, the interest rate question's not exactly SAT related, but we might go over it. Arcs is definitely more SAT related. So let's do this quadratic function and then see what next problem we could do. So here we have a quadratic function. The graph of y equals h of x intersects the x-axis at the points 0, 0, and t, comma 0. What is the value of t? Honestly, I would just Desmos this. But you'll notice if you sketch it out by hand, it opens upward the at when it is also in vertex form. Vertex form. From here, we can actually figure out that the vertex equals 4 comma negative 32. When I plug in x equals 4, I get negative 32, and it's symmetrical around x equals 4. So it's going to be somewhere like down here. It also tells us it passes through 0, 0. So it's going to pass through this point specifically. It's going to pass through a point over here somewhere. So let me label these points. This is at 4, comma negative 32. This point is at 0, 0. And this point is at t, 0. Yeah, this is at Algebra 2. And I specifically drew it like this. Admittedly, a little bit poorly. But I drew it like this because you can see a parabola is symmetric around the vertex. They gave it in vertex form. And so if one of the roots occurs at x equals 0, and the vertex is at x equals 4, the other one has to be symmetrical at x equals to 8. That gives us answer choice D. Ooh. Are we allowed to graph this during the SATs? Yes. You can go to Desmos. Because they've now built in a Desmos calculator into the test, you can plug in f of x equals 2x minus 4 squared minus 32, and you get the same graph that I drew out, just scaled a little bit differently. You'd also, like, from here, you can very quickly find that x is equal to 8 for that other solution. Yep. Yeah, let's do arcs. Let me go look for that. That's going to be in our geometry and trigonometry, specifically circles. So arcs. Let's start off with a little bit of an easier one, just finding some kind of angle measure, not actually calculating the arc length. Yeah, if it were x plus 2, the vertex would have been negative. Because it's always in the form x minus the vertex, or x minus h. X minus x vertex. Yeah. So arcs. This is kind of our warm-up problem for arcs. It's asking, or it gives us this diagram and asks, what is the radian measure of angle QOR? Radian measure of angle QOR. Well, I know that POQ right here and ROT are both 30 degrees. I know that a straight line is from here to, let's draw it like this. From here all the way over to here is 180 degrees. So QOR is 120 degrees, just subtracting off those two 30s. And to convert that into radians, you have to multiply by a conversion factor. That conversion factor specifically is going to be, well, how many radians are there per degree? There's pi radians in 180 degrees. Right. In a whole entire circle, you have to remember that there's 2 pi radians and 360 degrees. So we can simplify that to pi over 180. And so that cancels out the degrees. So that becomes 12 over 18 pi. That simplifies even further to 4, 6, or divide by 6 to get 2/3 pi. It's going to be answer choice C. Yeah, we got that. Let's do a couple more arc problems. Actually, this one is a good one. This one you don't have to explicitly use the formula or solve for it, but it still tests your understanding of these circles. So what I have here, circle has a circumference of 144 pi. Diameters are PR and QS. The length of arc PS is twice the length of arc PQ. There's PQ. What is the length of arc QR? Well, I know that this is, I can set this as x, right? Which would very conveniently make this 2x. Now these diameters split the circle evenly, so I can also label this up here x. I can label this on the side 2x. And I can add everything together to get 6x, which is equal to what? That's the whole circumference of the circle. Adding up all of the different constituent arcs, actually makes up the entire circumference of 144 pi. Okay, so now we can easily solve for x by dividing by 6, and x is 24 pi, which is not the correct answer because we're looking for the length of arc QR. From Q to R, it's a length of 2x. The arc length is 2x. So really, that's asking for 2x, which is 2 times 24 pi, which is 48 pi. I think I forgot to paste that question in, so let me put it in a chat for you guys with the solution. Yeah. And we've got the arc length formula in the chat if we need to use it. Arc length is equal to the proportion of the circle that you're looking at out of 360 degrees times the circumference. So sometimes people write it as like S equals x degrees over 360 times 2 pi r. But really, that's you're just taking a slice out of the circle and multiplying it by the circumference, because that's what an arc length is. It's just a small portion of the circumference. Okay. I think we've got time for... Oh, that is a really bad quality. I'm actually going to rewrite that. Determine a cube or a non-square root of a number without a calculator. I mean, just kind of guess and check, I guess. Okay, so let's rewrite this, because manipulating numbers on a SAT is pretty important. Manipulating things like equivalent expressions or finding equivalent expressions for something is important. Here, a over b over c. What I like to do when I have these nested like double fractions is rewrite any whole numbers also as fractions. So what I mean by that is I would write this as a over b divided by c over 1. And this is times a over 1 divided by b over c. Then I handle each one separately. And what I do with these nested divisions is I keep it, change it, flip it. That's the trick. You want to keep the a over b. You want to change it to a multiplication. And you want to flip the fraction down here to 1 over c. So a over b, dividing this a over b by c over 1 is the same thing as multiplying by 1 over c. That's pretty useful for us because this becomes a over bc. Then let's handle the second part. This right here becomes a over 1, change it to a multiplication, and flip that b over c to become c over b, which ends up equaling for us ac over b. So now let's plug these back in because we haven't actually performed this multiplication yet. Move everything back here to get a over bc times ac over b. It looks to me like the c terms will cancel out, the a terms will multiply, and the b terms will multiply. So we'll get a squared over b squared. That will be answer choice A, I'm pretty sure. We'll paste that in if you guys can't see the... I will put the recording up on YouTube. So if you guys are interested, I have my YouTube links at explore.dancetestprep.com. If you go to So this is the link. If you go here, you'll also find the SAT Bootcamp course that I just released. That's complete with a bunch of practice questions like this. Yeah, I have my newsletter on there. That's the link. Yeah, we've got my newsletter on there. I have all my social media, so you can find my YouTube channel where I post the recording. And I just released a boot camp where I have a live tutoring sessions complete with a course, and you get access to my adaptive learning platform. So if you guys are interested, check out that page for sure. This is basically just SAT help. Yeah, no problem. I'm glad to hear it. 10. Yes, this one is 10. We can get that quite simply using some algebra by substituting k equals 3. So x minus 1 equals 3. That's x minus 1 divided by 3 equals 3. Multiply by 3 to get x minus 1 equals 9. And then add 1 to get x equals 10. I see a lot of people submit this one actually. But yeah, it's x equals 10. I see. Yes, I am talking. Problem solving data analysis. Well, guys, it looks like I'm actually gonna have to head out here, but I do have a bunch more of these questions on YouTube. If you want to check out the explore page that I linked above, I also have more questions and examples like this in the bootcamp. Definitely join next week and submit your questions because I have a bunch more to paste in, and you guys can submit any topics or any questions you want. We'll cover those next week. But yeah, thanks for joining. We'll see you guys again on next week.